Hi, in this video we're looking at 2018 Maths Paper 1 question 4. This is a sequence question and it tells us that we have first three stages in a pattern of grey and white tiles which are shown in the diagram below. Part A of the question, we have to draw the next stage of the tiles, stage 4, onto the diagram below. So looking at the previous stages, I'm noticing that each stage the number of grey tiles along the horizontal direction is increasing by 1 and the number of grey tiles along the vertical direction is increasing by 1, forming a square of given size. So for stage 1 it's 2 by 2, for stage 2 3 by 3, stage 3 it's 4 by 4, so stage 4 is logical to expect that the square should be 5 by 5, 1, 2, 3, 4 and 5, and 1, 2, 3, 4, 5. Let's just count 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So these will be my grey squares. Let's color them fairly quickly. And each of the elements of the pattern has two additional squares. The white squares, one added above and one added to the side, and that forms the full pattern. So that's the first part. In the next part of the question we have to complete the table below. The number of grey tiles per stage, the number of white tiles per stage, and the total. I'll start with the number of the white tiles because this is the easiest part of the question. It's always equal to 2. Starting with stage 2, let's find out the number of grey tiles. So for stage 2 it's 9 from 3 by 3. For stage 3 it's 4 by 4, so 16. For stage 4 it's 5 by 5, so we'll have 25. And for stage 5, note that each stage stage number is 1 less than the number of tiles along the side of the grey square. So for stage 5 the length of the side will be 6 units, which means that the number of grey tiles is 36. If that's the case, I can find out the totals. 9 plus 2 is 11, 16 plus 2 18, 25 plus 2 is 27, and finally 36 plus 2 leaves me with 38. And that completes this part of the question. Next stage, we're looking at this problem continues. So now we have we're told that assuming the pattern continues, the total number of tiles in stage is given by a formula. So this is my formula where B and C belong to n. We have to find the value of B and the value of C. So just looking at my previous solutions, if n is the number of stage, T of stage 2 is equal to 11, and T of stage 3 is equal to 18. I know that from my previous calculations. So I can use those two facts to form a set of equations. So 11 equals to 2 squared plus B times 2 plus C. Also 18 equals to 3 squared plus B times 3 plus C. Let's simplify this. This is my system of equations. So 11 equals to 4 plus 2b plus c. 18 equals to 9 plus 3b plus c. Simplify further, but moving unknown and knowns to the same side. So I ending up with 7 equals to 2b plus c, and 9 equals to 3b plus c. I'm going to multiply this equation by -1, and then I'm going to add the two equations to end up with the following. So -7 equals to -2b minus c, and 9 equals to 3b plus c. Adding the two equations allows me to get rid of the c constant. So I'm ending up with 2 equals to b. And substituting this quantity back into one of my original equations, let's go over here. 11 equals to 4 plus 2 by 2 plus c. So simplify, 11 equals to 8 plus c. And from here I'm getting that c equals to 3 and b equals to 2. And that completes the solution for this part of the question. So the next thing is we have to find the number of the stage which has 443 times total. Now I can use the fact that t of n equals to n squared plus 2n plus 3 from the previous calculation. And I also know that this is equal to 443 for some stage n. So let's start simplifying. N squared plus 2n equals to 443. 440 because 3 is moved to the left hand side. Now forming a quadratic equation, I have n squared plus 2n minus 440 equals to 0. And I can do a couple of ways of solving it, but for me the simplest way is just do minus b, and you can practice this yourself using minus b plus or minus square root of b squared minus 4ac, all that over 2a. But for this I'm going to arrive at a solution that n equals to 20. And I can check it fairly quickly by substituting the values in. So 20 squared plus 2 times 20 plus 3 equals to 443, and it is correct. So this is one way of solving it. Another way actually would be to enumerate the number of patterns, or the number of tiles for each part of the pattern. So for instance, starting with the pattern again, we have 6, 11, we have 18, and so on and so on, all the way up to 443. And we would understand then that 443 shows up for the 20th stage, and that brings us to the solution of that question. It's a good place to stop.